Okay, this is Unit 2, Day 3, one-to-one functions. Alright, so one thing you have to memorize about one-to-one functions is you have to know that for every unique x, there's a unique y. So in easier terms, that means no repeating x's and, keyword here, and no repeating y's. Okay, it also passes the horizontal line test. Okay, now don't forget, it has to pass the vertical line test to even make it a function, and then once it's a function, if it passes the horizontal line test, it's one-to-one. So just kind of think of it as for every one x, there's one y. So no x's repeat and no y's repeat. Okay, so example 19 gives you this function f of x and g of x. It says map the domain using these functions. So for example, it says the domain of f. Now remember, domain means all the x values. So you're just going to substitute all of these x values into the function for f. So you're going to go 2 times negative 2, you're going to get negative 4. 2 times 0 is 0. And 2 times 2 is 4. Now it is a mapping, so you do have to connect and draw the arrows. And it kind of gives you the coordinates. So that on a graph would be the point negative 2, negative 4, 0, 0, and 2, 4. You can do the same thing for the g function, but it's x squared. Be careful. Negative 2 squared is 4. 0 squared is 0. But 2 squared is also 4. Okay? So it's basically showing you that with this function, you get a y value or a range value that's repeating. So part B says, what is fundamentally different between these two functions in terms of how the elements of this domain get mapped to the elements of its range? Well, basically, you're just kind of noticing that all the values of the range in the f function are different, but some of the range values in the g function repeat. Okay, so all values in the f function are unique, which means they're different, but some values in the range of the g function repeat. Okay? Alright, moving on here. One-to-one functions. Okay, again, just memorize every unique x has a unique y. In your own words, explain what it means for a function to be one-to-one. Each unique x has a unique y. So, easy words, no x's repeat. Oops, I can't spell. And no y's repeat. Again, example 21. Of the 4 tables below, one represents a relation where y is a one-to-one function. Determine which it is and explain why the others are not. Okay, so basically, if you just go through here, you need no x's repeating and no y's repeating. So this one's definitely not one-to-one because you have x's repeating. This one's not one-to-one because you have y values repeating. And then it looks like this one down here has some x values repeating. So hopefully by process of elimination it's 3, but if you look, every single x value is unique, every single y value is unique. Okay? Example 22. Consider the following 4 graphs which show a relationship between the variables x and y. Circle the 2 graphs above that are functions. Now remember, if it's a function, it's going to pass the vertical line test. Explain how you know they are functions. I just said that. So the ones that pass my vertical line test are going to be 1 and 4. It only hits the graph once. It says of those 2 graphs, so here's 1 and here's 4. They pass the vertical line. Which is one-to-one. So now, for it to be one-to-one, it has to pass the horizontal line test. Well, if you look at choice 1, it fails it because it's going to hit that twice. But choice 4 only hits it once when you do the horizontal line test. So it's going to be 4 passes the HLT. Okay? If you wanted to, too, you could write the coordinates that you could find and just see that all the x's are different and all the y's are different. Okay, so then this little box just talks about the horizontal line test. So example 23, which of the following graphs is a one-to-one function? Justify your answer. Okay, so it first has to even be a function. So choice 1's out because that's going to fail the vertical line test. All right, now it must pass the horizontal line test to be a one-to-one function. So number 1 got rid of wasn't even a function. So this one right here is going to fail. This one right here is going to fail. So this one passes the vertical and the horizontal line test. So it's choice 3. Okay, so I'm going to write must pass the VLT, vertical line test, making it a function, and the horizontal line test to make it a one-to-one function. Moving on to example 24. It says the distance that number x lies from the number 5 on a one-dimensional number line is given by that function, and it's d of x equals absolute value of x minus 5. Show by example that d of x is not a one-to-one function. Well, if you just use your graphing calculator, or you remember from algebra that an absolute value function, I used to teach the kids value v. So this is going to be transformation 5 units to the right. Again, if you don't remember that, just put it in your calculator. And then you get this little v there, okay, generically. And then all of a sudden, if you were to test this, it fails the horizontal line test. Therefore, it is not a one-to-one function. Okay, something big we talked about in class. You have to memorize inverse, okay? Inverse means you're going to switch the x and y values. Okay, so you switch your x and y. The notation for inverse is a subscript of -1 as well. All right, so consider the two functions. So these you can go pretty quick. I'm not going to do them all out by hand because we've done functions before, but basically just use your store key. So f of 5, you substitute a 5 into the f function, and you're going to get out an 11. Okay, g of 11, substitute an 11 to the g function, you get out a 5. Okay, b, f of 0. Guess what you get? 7 halves. And again, you could do these all out by hand to actually justify that. G of 7 halves gets out a 0. So you should be noticing a pattern. You put in 5, you get 11. You put in 11, you get 5. You put in 0, you get 7 halves. You put in 7 halves, you get 0. Okay? F of G of 5, you're going to substitute in. Guess what you get? You get 5. Okay, part D, f of g of -1, you get out a -1. So you should notice a little pattern here. Okay, and it's because why is this happening? Because those two functions are inverses. That's why this is happening, okay? So it says, without calculation, can you determine what that value is? Hopefully you're guessing, and it's pi. And again, the justification, it's because the two functions, the f function and the g function, are inverses of each other. Okay. So now we're just looking at this blurb about inverses. So basically, the domain of x becomes the range of the f function, and the domain of the g function, I think I might have said that wrong. So the domain of the f function becomes the range of the g function, and the domain of the g function becomes the range of the f function. So, as complex as that might seem, you're just switching the x and y values. That's all that means. And then something that I already pointed out to you, here's your notation that signifies an inverse function. Okay? All right, a function will have an inverse that is also a function if and only if it is one-to-one. Okay, so that's something to really pay attention to. So let's read that again. A function will have an inverse that is also a function if and only if it is a one-to-one function. Okay, so if it's a one-to-one function, its inverse will also be a function. That's what that means. Example 26. If the point -3, 5 lies on the graph of y equals f of x, then which point must lie on its inverse? Keyword inverse. So you switch x and y. So they gave you -3, 5. Switch x and y, and that becomes 5, -3. Choice 3. Example 27. Okay, this is a lot of reading on the graph here. So basically I'm going to take all these points here. It says use its graph to answer the following questions. Evaluate f at 6. So you're going to go over 1, 2, 3, 4, 5, 6. Its y value is up here at 2. So I know f of 6 is 2. Okay? Its inverse. Alright? Remember, its inverse means, so I'm going to kind of jump to part C. Okay, I'm going to jump to part C. So if 6 gives you 2, then 2 has to give you 6. Okay, so again, use this first point here. When you plugged in 6, you got out a 2. When you plug in a 2, you're going to get a 6. They're just reversing orders. Determine the y-intercept of -1. I'm sorry, the inverse function, so f of -1. Well, if the x-intercept on the given graph, which is over here, is at the point 3, 0, then its y-intercept is that value switch, which is going to be 0, 3. Okay, so if we were to plot that, that's up here. On the same set of axes, draw and graph the function of its inverse. So basically, I just kind of did one of them. So this right here was the point 3, 0. So if I reverse those, switch the order, it becomes 0, 3. Do that for all the real points that you can see. So this is the point 6, 2. Reverse it, it becomes 2, 6. Okay, this is the point 0, -2. So you plot -2, 0. This is the point -3, -4. So you plot -4, -3. Okay, and then this one is -6, -6. You switch it, it's that same point. So look at this. There's the inverse graph. Okay, and we talked about this in class. That is a reflection through the line y equals x. So the original graph and its inverse is always a reflection through the line y equals x. Back to our geometry days. Okay, last example here, example 28. A table of values for the quadratic function f of x equals x squared is given below along with its graph. So basically, here's a bunch of points in a table, and then here's its picture. Okay, so this is the original graph f of x. All right, part A. On the same set of axes, graph the inverse. Again, switch x and y. So this becomes 4, -2. All I did was look at this right here. Okay, and I'm going to switch them. So all of these range values, the y values, become the x values. All of the domain values, the x values, become the y values. So I'm just flip-flopping all of those. And then you're just going to plot them, okay? So here's 4, -2. Here's 1, -1. 0, 0 remains. 1, 1 remains. And then 4, 2. So here's my parabola of that inverse function. Okay, so here's the inverse function. And again, it should be a reflection through the line y equals x. Okay, so if you folded it on that line, there's your y equals x. It's a reflection. What did you notice about the graph of its function? Okay. I'm sorry. What do you notice about the graph of this function's inverse? Okay. Well, you should notice that the original one was a function. Okay, so the f of x, is a function, but its inverse is not a function. Okay, remember, if the original graph was 1-to-1, then its inverse would be a function. Well, this one's not 1-to-1, therefore that's not going to be a function.